All right, Danielle.
Data center benchmarking. Thank you, Colleen. We're going to get started today. We're going to cover pretty much everything you need to know about benchmarking data centers within Portfolio Manager. So first, we're going to go over the results of the poll that Colleen had posted at the beginning of the presentation. This was mostly just to get a sense of who our audience is on this presentation today. So Colleen, if you want to go over the results quickly.
Sure. So we do have a mixture of experience attending the webinar today. We have some new users, intermediate, and seasoned users. So this will be a good webinar for all. And actually, everyone has also a mixture of if there is the IT energy metering for your data centers. All answers were provided. And actually, the majority of the respondents also put NA because they do have the IT metering for data centers. So question 3 or 4 on the polling, since we added the short answer response, seemed to be most people are able to have the IT metering available.
Okay, great. I know there are a couple of people on the webinar today who had specifically asked about data center energy estimates at earlier dates, so we'll definitely go over those at the end of the presentation. But that's good to know because we do definitely encourage people to meter their IT energy, so it's good to know that most people are doing that. All right, so we can go ahead and move on. All right, so we'll start today's webinar by answering the question, what constitutes a data center? Then we'll move into a brief review of how the Energy Star score for data centers works, since it's a little bit different than most other property type scores, and the role that power usage effectiveness, or PUE, plays in the score calculation. We'll cover the items that users need to enter into Portfolio Manager in order to benchmark a data center, including use details and IT energy, and then we'll go into a few special cases of IT energy metering. We'll review how to verify indoor environmental standards for a data center when applying for Energy Star certification. And then we'll finish up today by covering data centers within larger office buildings. So for some context, we certified 105 standalone data centers in 2018, which is the highest number so far in a single year. But in terms of Energy Star certification, far more often than standalone data centers, far more common rather, are smaller data centers that are broken out as secondary property uses within larger office buildings. We see those a lot more often than we see standalone data centers on the review team. So we wanted to make sure to take some time to focus on those today. Two of the most important topics to learn about those particular kinds of data centers that don't really apply to standalone data centers are the rules surrounding data centers moving in and out of a building, and of course, as I mentioned, the new data center energy estimates that were introduced in August 2018. So we'll mention those a few times throughout the presentation, and we'll then get into the real detail about them at the very end. All right, so first, what constitutes a data center? A data center is a space that is specifically designed and equipped to meet the needs of high-density computing equipment, such as server racks used for data storage and processing. Data centers typically require a number of specialized pieces of equipment and design features, including a dedicated uninterruptible power supply, more commonly referred to as a UPS, as well as dedicated cooling to account for the heat generated by the servers. As a rule of thumb, data centers generally require a constant power load of 75 kilowatts or more. Smaller, high-density data centers within larger buildings may sometimes require less than that, but usually not by much if they're a true data center. And of course, large enterprise standalone data centers will require much, much higher power load than that. Finally, they typically require raised flooring systems, both for air circulation and for wiring and accessibility purposes. Data centers may be used for enterprise services, both traditional and on-demand, high-performance computing, or as internet and hosting facilities. And as we've already discussed, they can be standalone structures, or they may exist within a larger building, typically an office building. Especially when you're dealing with smaller spaces within a larger office building, it's important to be very specific about whether the space meets the definition of a data center or not for purposes of Energy Star benchmarking. A server room may share some features with a true data center, but if it's very small, if it's just like a server closet, or if its constant power load is significantly lower than 75 kilowatts, or if there's no dedicated cooling or no UPS, then it's probably not a true data center. If you're ever in doubt, you can always submit a support ticket via the building's help link, which will be provided at the end of the presentation. And if you provide us with the details of the space, we'll be able to help you out and decide whether the space is a true data center that meets the definition or not. So if you have a small space like a server room that doesn't meet the definition of a data center for other reasons, but it still does have dedicated 24/7 cooling, excuse me, and you don't want your score to be penalized due to this additional energy use for the cooling, which is what might happen if you just included that in your regular office use, then you can break it out as a separate office use in Portfolio Manager. In that case, you would enter it with 168 weekly operating hours, which reflects its 24/7 operation, 0 workers, and a number of computers equal to the number of servers in the space. Before we introduced the data center energy estimates back in August, which again we'll cover later in this presentation, this was how we advised people to benchmark any data center within a larger building that did not have proper IT energy metering in place. Now, however, this option should really only be used for spaces that don't meet the data center definition. A true data center without proper IT energy metering in place should use the data center energy estimates. Other space types that don't meet the data center definition are computer training areas, telecom closets, and print and copy rooms. Even though these spaces may have a higher than usual density of computers or computer-related equipment, they do not meet the definition of a data center, and they should instead be just included in the gross floor area of the building's primary property use, which is typically office. Now that we know what is and isn't a data center, we'll look at how data centers are scored. We'll be doing a high-level look at this in the interest of time, but if you'd like to dig into the weeds a little bit more, the Energy Star Score technical reference for data centers is linked on this slide, so you'll be able to check that out when the slides are sent out in the next day or two. Okay, so the general process for generating an Energy Star score starts with users entering their building energy and use data into Portfolio Manager. Portfolio Manager then uses the use details to predict how much energy that building uses based on data for similar buildings nationwide. Finally, the predicted energy use is compared to the building's actual energy use. If the building uses more than predicted, then the score is lower, and if it uses less than predicted, the score is higher. For most property types, there are multiple use details that Portfolio Manager uses to predict the building energy use. So we'll take offices as an example. Portfolio Manager uses the number of weekly operating hours, computers, and workers on the main shift, as well as the percent that can be heated or cooled, to predict the building's energy use. And in the case of offices, the energy use that it's predicting is the source energy use intensity, or EUI. That's the source energy use per square foot. And that's the metric used for most other property types as well. So if the actual building energy use per square foot is lower than the predicted energy use per square foot, then that building will score higher, and vice versa if they use more energy. Data centers are a little bit different. There's only one use detail used to predict the energy use, and that's the annual IT energy. This can be a little bit confusing. It's tough to think of IT energy as a use detail since it's entered in your Energy tab in Portfolio Manager, and it is energy use. Plus, if you're entering an energy use value, then what is Portfolio Manager actually predicting if it already knows your energy use? So 2 things to note as we answer this. First, you're not entering the whole building energy here just yet. You're just entering the IT energy. A data center uses more energy than just IT energy. IT energy is the energy used to power the IT equipment, like the servers, but a data center also uses cooling, lighting, plug loads, etc. Secondly, and most importantly, in the case of data centers, Portfolio Manager isn't predicting energy use per square foot, or EUI, like it does for other property types. Instead, what it's predicting is the power usage and effectiveness, or PUE. PUE is a measurement of efficiency that is specific to data centers. So for data centers, if the actual PUE is lower than the predicted PUE, your score will be higher. So let's talk about PUE and how it's used in the Energy Star score for data centers. PUE is equal to the total building energy divided by the IT energy. So for example, if a data center uses 20 million kilowatt hours total over the course of a year purchased from the grid, and 10 million of those kilowatt hours go towards powering the IT equipment, the IT energy, as IT energy, then the PUE would be 20 million over 10 million, or 2.0. So the obvious corollary to that is that the minimum theoretical value for PUE is 1.0. That's what would happen if 100% of the building energy went to IT energy. The data center in that case would obviously be dark, and it would need to have really good passive cooling in place to hit that minimum, since that means no energy is going towards anything else like lights or HVAC. That's why it's a theoretical minimum. No data center actually gets to 1.0. Some get pretty close, though. PUE measures how efficiently a data center uses energy. Since data centers are, by definition, going to use a large amount of energy, the kBTU per square foot measurement used for other property types isn't really useful like it is for other buildings. You're not necessarily trying to use less energy, since less energy means less computing power, but you're trying to use the energy that you do use really efficiently. And you want to have most of it go towards computing as opposed to cooling, lighting, and other overhead uses. So since PUE is equal to total data center consumption for all fuels divided by IT energy consumption, it's important to note a few things. Firstly, in Portfolio Manager, it's very important to make sure your whole building meters include all of your building energy, including all IT energy. Those meters should reflect 100% of energy used in the building, just like they would for any other property type. You'll of course enter your IT energy separately in IT energy meters, but again, you should think of the IT energy meters as more of a use detail, just like computers would be for offices, as opposed to thinking of it like a regular energy meter. You're not double counting this energy by making sure it's accounted for in both places. If you do exclude the IT energy from your main building meters for fear of double counting it, then your score will not be accurate. So make sure your IT energy is included in your main building meters. Let's look at an example PUE calculation. So we'll say your total building energy is 4 million kilowatt hours and your total IT energy is 2.8 million kilowatt hours. You divide those and you get a PUE of 1.43. This is a very good, efficient PUE. 2.0 for a lot of data centers is pretty standard. Energy Star certified data centers are typically in the 1.4 to 1.7 range, although they might be a little bit lower or higher. And obviously the goal is to get that number as low as possible through use of efficient HVAC systems, passive cooling, efficient lighting, etc. And one quick note on this. Portfolio Manager uses source energy to calculate your PUE, and to do that, it assumes that 100% of your IT energy comes from grid electricity as the source fuel. This is true in most cases, but if your IT energy comes from another source, such as natural gas-powered fuel cells, that's a fringe case that needs to be handled a little bit differently. So if that's the situation you're in, please submit a support ticket explaining your situation through the building's help link provided at the end of the presentation, and we'll be able to provide you with assistance. Okay, so now that we know the technical details of how data centers are scored, we're going to look at the practical details of benchmarking in Portfolio Manager. First, we'll talk about entering use details. Even though IT energy is the only detail that's used to calculate the predicted PUE of a data center, there are a few other details that Portfolio Manager asks for when you set up your property. The first is gross floor area, which is the first detail shown here on the slide. Data center gross floor area for a standalone data center should include everything within the exterior walls of the building. So that includes all raised floor computing areas, of course, server rack aisles, storage silos, control console areas, battery rooms, mechanical rooms, administrative areas, elevator shafts, stairways, break rooms, restrooms, everything in the building. For data centers within larger buildings, then any space specific to the data center should be included. But obviously things like general building mechanical rooms, hallways, break rooms, etc., those would not be included. They'd be included in the primary property type's gross floor area, which again would typically be office. The next use detail is whether to apply the data center energy estimates. We'll go over these in more detail later in the presentation, but for standalone data centers, the selection should always be no. IT energy configuration is the next use detail, and it's an important one, as this tells us where your IT energy meter is located and what loads it captures. So let's talk a little bit more about IT energy. The diagram on this slide is taken from our FAQ on how to meter a data center for Energy Star certification, and it shows a schematic of a typical data center metering scenario. So the brick wall on the left, that represents the exterior wall of the building. So you can see there that energy flows into the building through the building master meter. This captures 100% of building energy. After entering the building, the energy splits into two streams. The first stream, the upper arrow, represents all of the non-IT energy used for HVAC, lighting, plug loads, etc. And if this is a larger office building, then this stream also represents all the energy going to the rest of the building as well. The second stream goes into the data center, where it runs into the uninterruptible power supply, or UPS. The UPS uses some of that energy to run, stores some of it in a battery for later use in case of a power failure in the data center, and sends most of it through to the UPS output. That UPS output is marked by letter A on the diagram, and that's where we ideally want to meter IT energy. Ideally, all energy flowing out of the UPS output will go toward powering the IT equipment. So if we follow the flow a little further, we see location B, the PDU input. PDUs, or power distribution units, as their name suggests, distribute power to the IT equipment. In some cases, the IT energy meter can be placed at the PDU input instead of the UPS output, and we'll go over those cases later. You can also meter downstream from that at either the PDU output, location C, or at the IT equipment input, location D. However, neither of those last two metering locations are acceptable for purposes of Energy Star certification. So if you're planning to seek certification for your data center or for your building that contains a data center, be sure to meter your IT energy at the UPS output or in some cases at the PDU input. So we'll go over the specifics of those options now. The preferred metering location, IT energy metering option number 1, is to meter IT energy at the UPS output. This is for a variety of reasons, but the most important reason is that this is the location of the IT energy metering for the data centers included in the reference data set used to create the Energy Star score model. In order for the score to be valid and applicable, the metering methodology used in your building should mirror the method that was used for buildings in the reference data set as closely as possible. So besides meter location, the other important aspect of IT energy metering is what is actually being captured by the meter. Your IT energy meters should capture only IT equipment, that is servers, data storage, network devices, etc. Overhead loads such as HVAC, lighting, and plug loads should not be included in this meter's loads. There is an allowance for up to 10% of the IT energy meter's load to be non-IT loads, so we'll go over an example of that in a little more detail in a few minutes when we talk about special cases. But in general, your IT meter should capture only IT equipment. If the IT meter is capturing more than 10% of its load from non-IT equipment, however, you have two options. You can either submeter those loads and subtract them from your IT meter before entering IT Energy and Portfolio Manager, or if the non-IT loads branch off from the UPS load upstream of the PDU, as shown in the diagram, then you can put your IT meter at the input of the PDU, which is downstream from where that split happens. That will ensure that only IT loads are captured. So on to option number 2, metering at the PDU input. You can do this in two situations. First, if there's no UPS. Most data centers do have a UPS, but if yours does not for whatever reason, then you can meter at the PDU input. The second situation is the one we just talked about on the previous slide. You can meter at the PDU input if your UPS supports a non-IT load that is more than 10% of the total load captured by that meter, and if that non-IT load is not submetered. So in that case, if the load branches off upstream of the PDU, like we saw in that diagram, you can place the meter downstream of that branch at the PDU input, and that'll ensure that only IT loads are captured. The final IT energy metering option is more about method than location. Instead of using a kilowatt-hour energy meter, you can use a software solution connected to your UPS that will record kilowatt power readings at intervals of 15 minutes or more frequently. And then you can use those kW power measurements to calculate the kWh energy use. Kilowatt power measurements themselves will still need to be taken at the UPS output. And again, we'll cover this more when we talk about special cases. This is a summary of the IT energy configuration options in the drop-down menu in Portfolio Manager when you enter that use detail, and the corresponding physical location for the IT energy meter in each case. So for the first 3 scenarios, they all show the meter at the UPS output. These include situations where your UPS supports only IT equipment, if it supports non-IT equipment but at less than 10% of the total load, or it's more than 10% non-IT equipment, but that non-IT load is submetered and excluded. The next 2 scenarios are the ones we just described, where the meter may be placed at the PDU input. That's where the non-IT load on the UPS is not submetered, or if the facility has no UPS. And finally, if no configuration is selected, then the assumption is that there is no physical IT energy meter and that the data center energy estimates will be applied. To wrap up talking about IT energy configuration as a data center use detail, I wanted to go over what you'll be asked when you apply for Energy Star certification with the data center, assuming you're metering your IT energy. In the eligibility details section of your online application process, you'll see the alert shown here, which asks for 3 pieces of information. First, where is your IT energy meter physically located? Second, what loads does it capture? And third, is your IT energy included in your main building electric meters? That is, do your main electric meters capture 100% of electricity used in the building? The first 2 questions focus on the IT energy issues that we just went over, while the third goes back to the PUE issue described earlier, making sure that your IT energy is being accounted for both in your main building meters and in your IT energy meters. So if you get this alert, be sure to provide a complete and thorough response to all three parts of this question when you apply for certification. Otherwise, you'll receive follow-up questions from the review team because we need all of this information to review an application. Let's move on to the final use details for data centers: UPS system redundancy and cooling system redundancy. Neither of these use details are required for a score, but they may be helpful for you for tracking and informational purposes. In general, enterprise data centers will have backup UPS systems in case the primary UPS fails. Similarly, they may have backup cooling systems in case their primary cooling system fails. This is all just equipment meant to decrease the risk of something going wrong in the data center and ensuring the maximum amount of uptime and minimal data loss in the event of any kind of failure. All right, we've covered use details in IT energy, so let's move on to some IT energy special cases. The first special case we'll go over is one that we touched on briefly earlier, the 10% allowance for non-IT energy to be included on your IT energy meter. In this case, we're going to talk about its specific application for metering at the UPS input instead of the UPS output. This is not a recommended configuration and is generally not allowed for purposes of certification or scoring, but if there's just no way around it and that's the only IT energy meter data you have available, metered at the UPS input instead of the output, then in some cases the 10% allowance can be used to help with this. So first let's go over the 10% non-IT energy allowance a bit more. If your IT energy meter contains non-IT loads, then in order to report the total load as IT energy without submetering those non-IT loads out, you need to be able to quantitatively document that the non-IT load is less than 10% of your meter total. So for example, let's say you have an IT energy meter that captures only IT equipment, except for a single cooling unit, and let's say that cooling unit has a maximum power draw of 50 kilowatts. In order to quantitatively demonstrate that this cooling unit accounts for less than 10% of the energy included on that meter, you would need to show what the theoretical maximum amount of energy that unit could have used would be, and then demonstrate that that's less than 10% of what was metered. So if that 50 kilowatt unit were run 24/7, then we can calculate that it would consume a theoretical maximum of 438,000 kilowatt hours over the course of the year. That's 24 hours a day times 365 days a year times 50 kilowatts equals 438,000 kilowatt hours. So if the annual total on the meter is greater than 10 times that, or 4,380,000 kilowatt hours, then we know that the cooling unit could not have possibly accounted for more than 10% of the meter's annual load. So that would be allowable. But if the annual total on that meter is less than that, then it would likely not be allowed, or sometimes additional documentation might be necessary, showing maybe that that unit only ran for a certain number of hours or something like that. The bottom line here is that you need to be able to provide quantitative evidence that the non-IT loads account for less than 10% of the total metered energy on that IT meter. So how does this apply to metering at the UPS input versus the UPS output? Firstly, again, just to reiterate, if you're just setting up your IT energy meter, set it up at the UPS output, not at the input. This exception is meant for very rare cases where maybe an IT meter was incorrectly set up at the UPS input, and that's the only IT energy metering data available, and for some reason data center energy estimates are not an option. So for these rare cases where meter data is only available from the UPS input, here's how this exception works. For Energy Star purposes, the UPS itself is considered non-IT equipment. This is because metering is supposed to take place downstream of the UPS, so any energy consumed by the UPS itself is inherently excluded from that. So in this case, what you would need to do in order to allow UPS input metering is to quantitatively demonstrate that the UPS uses less than 10% of the total UPS input meter load. In other words, the UPS needs to be at least 90% efficient. And again, this needs to be quantitatively demonstrated using simultaneous kilowatt power readings from both the UPS input and the UPS output sampled over time. In this case, just providing equipment specifications saying that your UPS is at least 90% efficient, that's not sufficient. You would want the sampled kW readings from the UPS output to be no more than 10% lower than those sampled simultaneously at the UPS input. So again, this is a rare case, but if your data center is in this situation, please send a support ticket using the Ask a Question link at energystar.gov/buildingshelp. If you send us the building details, we'll be able to help you out and provide you with more information if you only have UPS input metering available. The second special case I wanted to mention is the one we touched on earlier. If you recall, option number 3 for your IT energy metering involved using a software solution to sample power load in kilowatts at intervals every 15 minutes or more frequently, and then to use those power readings to calculate the kilowatt hour IT energy use for your data center over the course of a year. Again, this kW sampling needs to take place at one of the acceptable IT energy metering locations, ideally the UPS output. The important thing I wanted to emphasize for this special case is that samples must be taken in intervals no longer than 15 minutes. We've received applications in the past for data centers that were sampling kW power load on an hourly basis or sometimes even a daily or even monthly basis, and they were using that single daily or monthly measurement to represent their data center load for that entire day or for that entire month. While data center loads are typically fairly constant, it's important to make sure that that's the case by sampling at least every 15 minutes. So an example of what this might look like is shown here, just for a 90-minute period. For that 90-minute period, each sampled reading represents a 15-minute window. So in this table, that 12 o'clock reading represents the window 12 to 12:15, and the final reading represents 1:15 to 1:30. So what we can see here is all the readings are somewhere around 120 kilowatts. So it's a fairly steady load, though not perfectly constant. So this level of sampling at every 15 minutes should capture any minor fluctuations. Each of those kilowatt readings are multiplied by the number of hours they represent. In this case, 15 minutes is a quarter of an hour, so 0.25. If you were sampling at 10-minute increments, those hourly increments would be 1/6 of an hour. They'd be 1/12 of an hour if you sampled every 5 minutes, etc. So each of these power times time measurements results in a kilowatt hour energy consumption for that 15-minute interval. And those are all added together to get that total energy use for that 90-minute period. Software built into your UPS or installed separately will be able to keep this up for a full year and use this sampling method instead of a direct kilowatt hour energy meter to obtain kilowatt hour energy use for your IT energy meter. And that'll be acceptable for purposes of Energy Star scoring and certification. Again, as long as you are sampling every 15 minutes or more frequently. All right, so let's move on to how to verify the indoor environmental standards for a data center. Data centers are different from most other property types in that their primary purpose is not for human occupancy, so the standards and requirements for data centers are going to be different from the requirements for other property types. First, for lighting, the important thing is that there is adequate illumination for performing work-related tasks in areas where workers go regularly. In areas not regularly occupied by workers, such as the server rack aisles, there just needs to be minimum illumination for safety and emergency functions. For ventilation, it just needs to be verified that workers at the data center have some level of acceptable ventilation to ensure they have access to fresh air. CO2 measurements can be taken to ensure that air quality is acceptable for human occupancy. And for human comfort and thermal conditions, these considerations only apply to spaces where people work regularly, such as offices, security desks, and monitoring stations. Server areas are obviously going to be conditioned based on the requirements of the equipment, so it's acceptable for these spaces to be hotter than would be comfortable for normal working conditions. It's not expected that people will be spending extended amounts of time in those areas. So everything we've discussed so far has focused mainly on standalone data centers, though from a certification standpoint, the majority of data centers we see exist within larger office buildings. So we're now going to take some time to focus on issues specific to data centers within larger buildings. First, let's briefly go over setting up this kind of property in Portfolio Manager. If you're first setting up your property, let's say it's an office, you'll see this box on the initial setup screen asking if any of these situations apply: parking areas, data centers, retail stores, and restaurants or cafeterias. You would check the box indicating that your property has a data center that requires a constant power load of 75 kilowatts or more. Then on the next screen, you'll enter your use details for both the office and the data center. So first, you'll enter the office use details as shown here. In this case, let's say we have an office building that's 400,000 square feet, and the office portion of the building is 300,000 square feet out of that total 400,000. You'd enter your other use details for the office next, including weekly operating hours, number of workers on the main shift, number of computers, and the percent that can be heated and cooled. Again, all of those details should apply only to the office space. Next, you'll enter your data center use details, which we went over earlier. In this case, the data center is 100,000 square feet, That's 25% of the 400,000 square foot building. The other 75% is the 300,000 square feet of office space that we just entered. All right, now what if you have an existing property that you need to add a data center to, rather than setting up the whole property from scratch? In that case, you would access the Details tab of your existing property and use the Add Another Type of Use drop-down menu to select a data center, and then click Add. You'd then be taken to the same type of data entry screen we just saw in the previous slide to enter your use details for the new data center property use. When you add a data center, or any property use, but in this case a data center, to an existing property, always make sure to adjust your existing gross floor area of the primary property use so that the total gross floor area of the building is accurate. So for example, let's say we have this 130,000 square foot office building and a data center moves in. So we would add that 30,000 square foot data center, and then we'd go back to the Details tab, and as you can see in the second screenshot there, the gross floor area is the sum of these, or now 160,000 square feet. So obviously the building didn't just grow by 30,000 square feet. So we need to go and update the office property use with new information. What actually happened is that 30,000 square feet of office space was converted into data center space. So when the data center space is added, 30,000 square feet of office space goes away. And so that results in the correct total property gross floor area of 130,000 square feet that we see in the final screenshot. All right, so now let's go over the specifics of data centers moving in and out of a building. For data centers moving into a building, an important thing to remember is that you need at least 9 months of IT energy to get a score for the data center, assuming you're metering your IT energy. So if you add a data center to the property using the steps we just outlined, and you start entering IT energy for your data center, then you have 4 options. First, you can just wait 9 months to get a score. That's going to be the most straightforward and accurate option, though of course it means you won't have a score for 9 months. So if not having a score for 9 months presents an issue because you want to apply for certification or for some other reason, then your second option is to use the data center energy estimates for the first 9 months. You can still enter your metered IT energy during this time, but if you have data center energy estimates selected as yes in your Details tab, that Portfolio Manager won't take the metered IT energy into account. Once you've gathered 9 months of IT energy data, you can then change your estimate selection to no, and Portfolio Manager will then use that metered IT energy to calculate your score. The third option is essentially a workaround. What you do is enter your data center as if it had already been around for 9 months. This option is a little more complicated since you need to vary the use details over time. So as an example, let's say you had a data center move into your building on October 1st, 2018. 9 months before October 1st is January 1st, 2018. So when you first add your data center, you'd enter your data center gross floor area as 0 square feet with a current as of date of January 1st, 9 months before it actually moved in. You'd enter IT energy as 0 kilowatt hours for that period of January 1st through September 30th. And then you'd need to update your data center use with new information. And using a current as of date of October 1st, you would change your gross floor area to the actual area of the data center. You'd adjust the office gross floor area accordingly as well, and start entering your actual IT energy data as of October 1st. Please note that you cannot use this option for Energy Star certification. You would still need to at least 9 months of actual non-zero IT energy on your certification application. The final option is to track the data center as an office for the first 9 months. You can benchmark it as 24/7 office space, similar to how we talked about benchmarking a smaller server room earlier in the presentation. And just like with that example, though, this option is not recommended for data centers that are eligible to use the data center energy estimates option. If possible, you should use the estimates instead. Linked at the bottom of this slide is the FAQ for adding a new property use to an existing property. So be sure to follow the general steps in that FAQ whenever you add a data center to an existing property, while keeping these data center specific policies in mind. The rules are similar for data centers moving out of a building. Again, you need at least 9 months of IT energy. That's required to get a score. So for the first 3 months after a data center moves out, you'll still have a score. During the next 9 months, months 4 through 12 after the data center moves out, again, you have 3 options. First option is, again, to just wait 9 months for a score. This will be the most accurate and simplest option, just like before, but again, it'll mean that you don't have a score for those 9 months. So if not having a score for 9 months is an issue, then your second option is to use the data center energy estimates for months 4 through 12 after the move out. You would update your data center use to have a gross floor area of 0 square feet as of the move out date, and then you would select yes to apply data center energy estimates. Your third option is the same as the third option for a data center move in, which is to update the data center with a gross floor area of 0 square feet and enter 0 IT energy for months 4 through 12. And again, as with the move in, this option will result in a slightly inflated score, so it's not an option you can use if you want to earn Energy Star certification. Whichever of the move out options you choose, you have two options for actually removing the data center from your property in Portfolio Manager. The first option is the recommended option, which is just to modify the data center property use to reflect the move out, but don't actually delete it. Instead, what you would do is use the Update with New Information option in the drop-down menu on your Details tab to change your gross floor area to 0 as of the move-out date. You would then update your primary property use back up to its original value to keep the total property gross floor area consistent. And then you'd set your IT energy meter to inactive as of the move-out date. If you use this option, it'll ensure that you can retain all of your historical data. So any historical metrics that you calculate, any reports, things like that, they'll all be accurate in the future. For option 2, you can just delete the data center use altogether if you wish, but that's generally not recommended because, again, that'll affect your historical metrics since you'll lose all the historical data associated with that data center. So assuming you choose option number 1, let's go through the details of that option, which is modifying the data center property use to reflect the move out. So we start off with the first screenshot showing a 130,000 square foot building made up of 100,000 square feet of office and 30,000 square feet of data center. First, we'll use the drop-down menu next to the data center use to select Update with New Information. Then we update the gross floor area from 30,000 square feet to 0 square feet as of the date of the move out, which in this case we're going to say is February 1st, 2019. We save this, and then we go back to the Details tab, which we can see at the top of the right side of the slide. You'll notice now on the Details tab that the data center gross floor area looks a little weird. It's at just over 25,000 square feet, which is not a number we ever entered. The reason for this is that this is a time-weighted value. Remember that Energy Star scores are based on 12 months of data, and this particular property's metrics go through March 2019, so it's based on a 12-month period of April 2018 through March 2019. So as time goes on, that value will go down month to month. And 12 months after that move-out date of February 1st, 2019, the 12-month time-weighted value will finally go down to 0. So now we can see that the time-weighted total gross floor area is off too, and that's because we haven't updated the office gross floor area yet. So in the middle of the right side of the slide, you can see we update the office use with new information. We update the gross floor area from 100,000 to 130,000 square feet, again, as of the date of the move-out, February 1st. We then save this, and now back on our Details tab, we can see that the total time-weighted gross floor area of the building is back to being accurate at 130,000 square feet. The second part of removing the data center using this option is to deactivate the IT energy meter, which is pretty straightforward. You would access the meter from your Energy tab, expand the basic meter information section, and then where it says still in use, you would just uncheck that box, and for the date the meter becomes inactive, you would enter the move-out date. So again, in this case, that's February 1st, 2019. For the final topic in today's webinar, we're going to talk about the data center energy estimates introduced in August 2018. We've mentioned them several times throughout the rest of the presentation, so now let's get into the details of how they actually work. As we previously discussed, the data center energy estimates are only available for data centers located within larger office buildings. Standalone data centers should always use metered IT energy, as should data centers within larger buildings where they can. The estimates are designed for small data centers that do not have EPA-compliant IT energy metering in place. So let's go over the eligibility criteria and some other rules for using the data center energy estimates. Firstly, the total gross floor area of any data center using estimates, plus the area of any other non-scorable space in the building, needs to be no more than 25% of the total property gross floor area. For more seasoned portfolio manager users, you're probably aware of the rule that limits the amount of non-scorable space in a building to 25%. Above that, the building won't receive a score. So in this case, applying data center energy estimates essentially is turning your data center into non-scorable space. so it needs to be included in that 25% maximum. So for example, let's say you have a 100,000 square foot office building, and let's say it contains a 20,000 square foot restaurant and a 7,000 square foot data center. Restaurants are also non-scorable space, so if you use the data center energy estimates for your data center in this case, your property won't receive a score because that's 27,000 square feet, or in this case 27% of the building, that's non-scorable. If the data center were only 4,000 square feet, then your total non-scorable space would only be 24% of the building area. So in that case, you could still use estimates and receive a score. The other important thing to note about the data center energy estimates is that there's a 10% cap on the adjustment of the property's gross floor area. So what does that mean? What that means is that if you use the estimates for a data center that's larger than 10% of the building's gross floor area, the adjustment will be applied as if the data center were only 10% of the gross floor area. This is because the estimates option is intended for small data centers that do not have separate IT energy metering. The 10% cap prevents larger data centers, which really should have EPA compliant metering in place, from getting a disproportionately large credit in their score. So for example, if you have a 100,000 square foot building that includes a 20,000 square foot data center, the estimates adjustment that Portfolio Manager performs will treat that data center as if it were only 10,000 square feet, or 10% of the building's gross floor area. So that's what the cap means. Also, it's important to remember that in order to use data center energy estimates, the space in question needs to actually fit the definition of a data center that we went over earlier. So if you apply for Energy Star certification with a building that contains a data center using estimates, you'll see this eligibility alert, which asks you for the details of the space to make sure that it's a real data center, as opposed to a server closet or another type of space that doesn't meet the data center definition. So if you encounter this alert, then as always, be sure to provide a complete and thorough response that answers all of the questions posed by the alert. Any missing information will result in an email from the review team, which will slow down the processing of your application. So let's find out some more about exactly how the estimates calculation works. First, it's important to clarify that the data center energy estimates are not the same thing as IT energy estimates. Some of our more seasoned Portfolio Manager users might recall that prior to summer of 2013, users had the option to apply IT energy estimates to their data center. What those estimates would do is basically treat your data center as though it had an IT energy meter with metered energy, but it would just plug in conservative estimates for that IT energy and use those estimates generated by Portfolio Manager and use those to calculate your score instead of actual metered IT energy. So the newer data center energy estimates are not the same thing. So remember back when we discussed PUE earlier and we made the distinction between IT energy, which is energy used by IT equipment only, versus total data center energy, which includes all the energy consumed by the data center, including not only the IT equipment, but also cooling, lighting, security, plug loads, etc. While the old IT energy estimates from 2013 and earlier just estimated IT energy, the new data center energy estimates estimate the total energy used by the data center. And that's based on data obtained from the 2012 CBEX survey. The data from that survey informed an analysis that generated an estimated amount of energy per square foot that a typical data center within a larger office building would use. So now, when you apply for data center energy estimates, what Portfolio Manager does is it estimates how much total energy your data center uses, and then it uses that estimate to essentially exclude the data center from your building before calculating your score. If anybody's familiar with how Portfolio Manager handles parking, it's the same thing. Estimates the amount of energy it would use using an engineering estimate, and then excludes it before calculating your score. So let's go through a sample calculation. Portfolio Manager estimates that a typical data center will use about 2,000 kBTU of total energy each year per square foot of data center space. So if we use the example from the screenshot here, and say we have a 130,000 square foot building, 30,000 square feet of which is a data center. So 30,000 square feet is about 23% of the total building gross floor area. So in this case, we need to apply the 10% cap that I mentioned earlier. 10% of 130,000 square feet is 13,000 square feet. So we're going to estimate the data center energy as though the data center is 13,000 square feet instead of 30,000. So then we calculate how much estimated energy that space will use. 2,000 kBTU times 13,000 square feet equals 26 million kBTU. That's the amount of energy that Portfolio Manager estimates this data center will use. Again, making the assumption that it's only 10% of the building area instead of 23% because of that 10% cap. Now let's say that the building's actual annual source energy use intensity, or EUI, that is its energy use per square foot in the whole building, let's say that's 280 kBTU per square foot. So for a 130,000 square foot building, that translates to a total energy use in the building of 36,400,000 kBTU. So now we subtract the data center from that. So first we subtract the energy. Total building energy minus the estimated data center energy leaves us with 10.4 million kBTU used in the rest of the building. Now to get the adjusted source EUI for the building, we divide that total of 10.4 million kBTU by the square footage of the actual non-data center space in the building, which in this case is 100,000 square feet. So that gives us an adjusted EUI of 104 kBTU per square foot after the estimates do the work of excluding the data center. So this 104, this is the EUI that is used in the score calculation. So that's what is compared to the predicted EUI for an equivalent building, excluding the data center. So in this case, just a 100,000 square foot office building. And the results of that comparison will yield a score. Note that the EUI that shows up in Portfolio Manager and on your application will still reflect the actual EUI of the total building, including the data center and its energy. So in this case, what you'll see on your application and in Portfolio Manager will still be that 280 kBTU per square foot. But the value that's used to calculate the score behind the scenes would be 104 kBTU per square foot. So this is a pretty technical example, and if you'd like to dive a little bit more into the weeds on this, you can refer to the Data Center Estimates Technical Reference, which is linked on this slide. But this is meant to be sort of a high-level review of how this calculation works mathematically. Finally, here are some other details on the estimates option. If you have multiple data center property uses broken out, then estimates may be applied for all of them, for none of them, or for anything in between. So this may be useful if you have multiple data center tenants, some of which have EPA-compliant IT energy metering, and some of which do not. Also, you may choose to enter IT energy meter data into a Portfolio Manager IT energy meter, even if you are applying data center estimates to the associated data center property use. However, if you do this, the metered IT energy will not be reflected in the score. The estimate option will override the IT energy meter in this case. This may be something you choose to do if a new data center moves into your building, as we previously discussed. So for the first 9 months after it moves in, you might apply estimates so that you can still get a score, but in the meantime, you're still recording your IT energy use. And then once you have the required 9 months of IT energy recorded, you would change your estimate selection from yes to no, use the correct mistakes option in your details tab to do that, and then Portfolio Manager will then start using your actual metered IT energy in the score calculation. So this leads us nicely into our next point, which is that if you're applying data center energy estimates for any portion of a given 12-month period, then the estimates will be applied for that entire 12-month period when calculating the score. So be sure to check your current as-of dates in Portfolio Manager if you switch back and forth between using estimates and not using estimates. Because if there's even one day during your 12-month scoring period where estimates are being applied, then they'll be applied for the full 12 months. And any metered IT energy for the data center will be ignored. So finally, it's important to note that data center energy estimates will generally result in a score that's more conservative than if you were using actual IT energy metering. And this is intentional. Since this is an estimate, we want to make sure it's not over-crediting anyone, so it's intentionally conservative. And hopefully in some cases that'll serve as an incentive to install proper EPA-compliant metering, which will likely increase your score. However, prior to the introduction of the estimates, the guidance we used to give for benchmarking a data center without EPA-compliant IT energy metering was what we went over before, benchmarking it as a 24/7 office space, 168 weekly operating hours, 0 workers, etc. So that's still the same way we advise you to benchmark smaller server closets that have 24/7 dedicated cooling, but that do not meet the data center definition. But for data centers that do meet the definition, you should now be using the estimates. Benchmarking using the estimates will generally result in a higher score than using this 24/7 office method. So for anybody that has data centers in your building that meet the data center definition, that are still being benchmarked as 24/7 office space, we would encourage you to switch those spaces over from offices to data centers and to use the data center energy estimates where possible. That should generally give you a little bit of a bump in your score. That about wraps it up. So we have here a list of additional resources, including a list of 5 simple ways to avoid energy waste in your data center that can help you create and maintain an efficient data center and improve your building score. We also have links to our data center FAQs, plus some general resources on Portfolio Manager, along with upcoming webinars and recorded webinars. If you can't find the answer to your question in our FAQs or in any of these other places, you're always free to submit a support ticket at www.energystar.gov/buildingshelp. All right, thank you again. If you have questions, please enter them in the chat window. Since we're running a little bit short on time, we only have about 8 minutes left. I think what we're going to do today, instead of having a live Q&A, is I'm going to just take the questions that people have asked and I'll respond via email. If it's a very specific question that relates only to your data center, I'll send you an email directly that will answer your question. But if it is a more general question that I think could apply to multiple people, we'll include a sort of a compiled Q&A document that will go out with the recording and the slides. So you'll still get an answer to your question. We just won't be doing it today live on the webinar, but you should receive it probably within the next 24 hours. So we'll leave the window open a couple more minutes to let people enter their questions, and then we'll probably close out in about 2 or 3 minutes. So thank you again for attending, everybody. Go ahead and enter questions if you have them, and we'll get back to you shortly on those.